Okay, we're going to start a unit on quadratic functions, and today we're just going to be looking at some different properties and things of quadratics. So you can follow along, and if you'd like to, take notes, and we'll see several things about them if I can get my slides to move. Okay, first of all, a quadratic function or a quadratic equation can be written in standard form. When it's written in standard form, you're going to have an x squared term that comes first. We call that, the number in front of it is the a. You're going to have the x term second. We call the coefficient in front of it b. And the constant, or the number without the variable, goes last. So it goes in standard form like this. The a can never be 0. That means there has to be an x squared. So that's your hint. Just look for x squared. You can't have anything larger than an x squared. You can't have x cubed, x to the 4th power. The highest exponent on the variable is 2, and that makes it quadratic. For example, right here, you'll see it's in standard form, and x squared is the highest degree, so that's quadratic. If you remember us naming polynomials before, this would have been a quadratic trinomial because the highest degree was 2, and that's what we're looking for. The highest degree has to be 2. This was not written in standard form, but if it was written in standard form, you would move the y to the other side and move the 6 over here, so you'd have x squared minus 6 equals y. Well, again, this is a binomial, but it's quadratic because the highest degree is 2. And again here, the highest degree on any of those terms is 2, so it's quadratic. Another way to identify whether something is quadratic, if you have a table with the order pairs, you can identify whether or not this will graph as a quadratic function by checking to see if the second differences are constant. I'm going to show you what that means. Let's back up for just a minute. Quadratic functions, when you graph them, they're going to graph as a parabola. Looks like a U, either upside down or the other way. So if I were to ask you, is this a quadratic function? You should be able to figure it out without having to graph it. What we do is first we look at to see if the x's have a constant, if they're a constant. So -1 to 0 is a +1, 0 to 1 is a +1. Are these a +1? You can see it's the same pattern all the way. Each time you're adding 1, you're looking for that. Now, in the y, in the range, let's see what this is. To go from 16 to 2, that would be subtracting 14. To go from 2 to -2, that would be subtracting 4. Notice that these are not constant. These are not the same. Written out here. To go from -2 to 4, you're actually doing a +6. To go from 4 to 20, you're doing a +16. And to go from 20 to 46 is a +26. So there is nothing constant about this at all. What we're going to do now is find the second set of differences. So now we're going to take these values and say, well, what do I do to go from -14 to -4? Well, that's a +10. To go from -4 to +6 is also a +10. 6 to 16 is a +10. So even though these looked very random, when we got to the second set of differences is what we call it, notice that they're constant. So this is a quadratic function. When the second differences are constant, it is a quadratic equation. Now this is the same thing, except instead of the table being presented vertically, it's presented horizontally. So across the top is the x, or the domain. Notice each time it goes up by 1, so it's constant. But we need to check the y's. So to go from 0 to 1, that's +1. 0 to 4 is +3, +5, and +7. They're not constant. So now we want to check the second set. We want to do the same thing one more time. To go from 1 to 3, that's +2. 3 to 5 is +2. And 5 to 7 is +2. Notice that the second set is constant. So this would be a quadratic function if you were to graph it, because the second set is constant. Here, it's just presented a little bit differently. Instead of being in a vertical or a horizontal table, you'll see there's a list of ordered pairs. It helps you. You could organize them into a table. If not, you could look at it this way: -2 to -1. To do that, I have to. I love it when it does that. You have to add 1 each time it's going up by 1, so that's good. For the y's, we would check the do. 4 to 1 is a -3. 1 to 0 is a -1. 0 to 1 is a +1. 1 to 4 is a +3. Notice that they're not the same. To go from a -3 to a -1, you do +2, and it's +2, and it's +2. So that would be a quadratic. Oh, looky there. The PowerPoint did it for me. A quadratic function because the second set is constant. Now this next example, again, I took the order pairs and I'm just going to organize them into a table because it's a little easier to look at. Notice what happens here in the first set. When you go from 15 to 7, that's +2. 17 to 19, +2, +2, +2. We actually found that they were constant in the first set. When this happens, this is not quadratic. This is actually a linear function. When you graph it, it would be a straight line. So if the first set is constant, it is a linear function. If the second set is constant, it is a quadratic. Okay, this is kind of what I would call part 3 now. We are going to actually practice graphing. So we have a quadratic equation. It's quadratic because the highest degree of any term in this is a 2. We're going to do the same thing that we did when we were graphing linear functions. We have an equation. In order to graph order pairs, we need an x and a y. So we're going to pick some x or domains. We always like to pick the ones that are closest to the center just to make it graphing easier. So if they're not given to you, you might choose these. And you're going to plug them in. So here, for example, we know that you plug in -2 to x. When you plug it in, it goes into parentheses. When evaluating this, this says -2 squared. -2 squared is -2 times -2, which is a +4. 4 minus 2 is 2. So our order pair that we created was the -2 here from our x. And we saw this, and that was our y. So our order pair is -2, 2. So we're going to be able to go over here and graph that point. If we plug in -1, -1 is a +1. -2 would be negative. The pair is -1, -1. If we plug in 0, 0 squared is 0, -2 would be -2. So our order pair is 0, -2. I didn't graph that right. Whoops, sorry about that. Wasn't thinking. -1, -1 is down here. Sorry about that. 0, -2 is down here. Now we plug in 1. 1 squared is 1 minus 2 is -1. So we have right here. And when we plug in 2, 2 squared is 4. 4 minus 2 is 2. So we have 2, 2. Okay, so notice now once you get your ordered pairs graphed, it's going to make a parabola. So we're going to start down at either the maximum or the minimum. And we're going to make it a kind of a curved line up like that with arrows at the end. So it should look like that. It should not be a V. You want these to be curved like this. Okay, so it should look like that when you graph it. With a parabola, you're always going to notice that if you remember the word symmetry from geometry, there's going to be what we call an axis of symmetry. You would be able to draw a straight line down this, and it's the same on both sides. That axis of symmetry is going to be important as we move forward. But right now we're just practicing graphing. Here's another one, same practice. We're just going to plug in the numbers. So with this first one, if you plugged in -2 to x, when evaluating, we have to evaluate this part first, exponents first. So you have to do -2 squared. -2 times -2 is a +4. Then you can multiply that 4 times the -2, which is -8. Plus a +1 is -7. So our order pair is -2, -7, which is right there. Ooh, I need to recalibrate my smartboard. I'm not right on. Okay, we plug in -1. -1 squared is what we're going to do first. -1 squared, -1 times -1 is a +1, times -2 is -2, plus a +1, so we have -1, -1. Ooh, I need to recalibrate. If we plug in 0, basically this whole part of the thing goes away because 0 squared is 0, and 0 times -2 is 0, and we just have 1 left, so that would be 0, 1. If we plug in 1, we're first going to do 1 squared times -2 would be -2 plus 1, which is a -1, so we have 1, -1. I know I'm kind of talking through that kind of quickly. Okay, so you do your 2 squared first. 2 times 2 is 4. 4 times -2 is -8, plus a +1 is -7, so it would be 2, -7. Again, when you're drawing your parabola, it's going to be curved. Notice that there's an axis of symmetry. There's a line of symmetry that you can draw down through the middle of it. So we're just practicing getting a list of ordered pairs from our function and graphing it. Let's look at some other attributes of quadratic functions. You can actually tell by looking at the equation whether the parabola is going to open upward or open downward. If you look at the first equation here, y equals x squared minus 2, if I were to graph this, you would see how it's graphed. Notice that it's going up. On the next one, we have -2 x squared plus 1. When we graph it, notice it's going down. So how can you tell whether a parabola is upward or downward? All you have to do is look at the coefficient, the number in front of the x squared term. Now, if there's no number, it's an invisible 1, a +1. So this is a +1. This is a -2. If it is positive, if it's greater than 0, the graph is going to open upward. If it's a negative, which means that it's less than 0, that makes it negative, the graph is going to open downward. So these definitions down here, if a is greater than 0, or if it's a positive number, it's going to open upward. If it's less than 0, which makes it a negative number, it's going to open downward. So you should be able to tell just by looking at the quadratic equation whether it's going to open up or down. Okay, so look at this. Would this open up or down? This is a +4, so it's going to open upward. So when you graph it, it's going to be up like this. And this equation, this only works once the equation is written in standard form. Standard form is when you get the y by itself and you move everything else to the other side. So to put this in standard form, I want to keep the y on the left side of the equation. I have to move this over here, and since I want it in standard form, the x squared term has to come first. So I would say y equals, and when it jumps the fence over here, from a positive, it becomes a -2x squared, and it tells the 5 to scoot over. So when that moves to the other side to put it in standard form, notice that the leading coefficient becomes negative. So that would open downward. So before you can make this determination, you have to make sure it's in standard form, which is the y by itself and the x terms on the other side. Okay, again, this one is not in standard form. We want the y by itself. So this is the term we're looking at because this is the x squared term. We have to move it to the other side when it jumps the fence. This is the fence, the equal sign. It goes from a negative to a positive. So that would be a positive 5x squared, so that would open upward. The vertex is another word you're going to be hearing from a parabola. So when you have a parabola, the vertex is going to be either the very lowest point or it's going to be the very highest point. Okay? Now, obviously, that if it opens upward, the vertex is going to be the lowest point. This is the vertex. It's the lowest point of the parabola. If the parabola opens downward, obviously, this is the vertex. It is the highest point on it. Determine the maximum and the minimum values of the parabola. Okay, so if it opens upward, the minimum is the lowest point. So this, we would say this is the minimum because everything above it is higher Think about this y number line right here. This is a number line. As you go up, it becomes more positive. So this is the lowest it could be, the lowest possible value. So this vertex would be the minimum. When it opens downward, the vertex is the maximum. It's the highest it can be. So the highest value that this could be would be wherever it is on this y number line. Here on the y number line, it was a -4. That was the minimum because everything else was above it. Here, the maximum or the highest point would be a 1. So the maximum is a +1. So you look at the vertex and where it is on the y number line to find. Identify the vertex and determine the maximum and minimum values. Well, the vertex is going to be right here. That is the lowest point of the parabola, so that is the minimum, and it happens to be where on the y? 2. The minimum is 2, and the vertex is 0, 2. Here, the vertex is right here, so that order pair would be 3, 7, and since that's the highest point, that is the maximum. And the maximum is 7. That means that's the highest it goes on the y number line. So the maximum is 7. Finding the domain and range. Remember, the domain is the x. So you're going to look at the x number line, and you're going to think about where, if this parabola has arrows, now sometimes it'll have a point like this. That means it has a definite beginning and definite ending. If it does not have a point at the end, notice that the points are here and here. It's an understood arrow at the end, which means this is going to go indefinitely, get wider. I didn't draw that very well. As it goes wider and wider and wider and wider. So when does it quit on this x number line? Where is it going to stretch on the x number line for the domain if it goes indefinitely farther and farther apart? And to find the range, we're thinking, where is it on the y number line? Well, it has a minimum. It starts at the 2 and goes up. So here's how we write it. Since this parabola goes up and the lines go indefinitely in both directions, the domain is all real numbers because it's going to keep getting wider and wider and wider. You're going to keep stretching across that x number line. All we can say is all real numbers. The range, we're going to use an inequality, okay? Because, look, it's an inequality. We have our point. We have an arrow. It looks like a ray from geometry. The lowest point, it's y because it's on the y number line. It's greater than or equal to the -1 because it started at -1, it hits the -1 with a point and keeps going up. So we write the range in the domain. Sometimes it's written as all real numbers if it goes indefinitely in both directions. Otherwise, it's going to be written as an inequality. Okay, find the domain and range. So let's look at this one. There are no points. Now, if this had a dot or a point drawn at the end, we knew it would end right there. It's not going to go any farther. But because it doesn't do that, we assume that there are arrows. That means it's going to go indefinitely. It's going to get wider and wider and wider. So the domain would be all real numbers because on this x-axis, it would just keep stretching wider and wider. My pen quit. Well, okay, so I think I got this working. So we think about the domain. If there were arrows going indefinitely in both directions, then we would say that the domain is all real numbers. For the range, okay, it starts way up here at 4 and it goes down. So y, which is because we're on the y number line, is less than or equal to 4 because here's it is on 4 and it's going to all the numbers that are less than for that. So the domain is all real numbers and the range is y is less than or equal to 4. For this one, again, the domain and the range, there are no arrows, there's no points. So we assume that there's arrows at the end. So the domain would just be all real numbers. For the range, which we're going to use y for the range because we are on the y-axis, it starts at -4 and it's greater than or equal to -4 because it's going up. So the range is greater than or negative. Greater than or. Okay, I know there's been a lot in this lesson, but I want to show you 3 of the practice worksheets that I gave you and how you would look at them. This is the first one. It basically goes through the things that we went through in the notes and in the lesson, which was a lot. First of all, tell whether each function is quadratic. Again, we're looking for the second set of differences. So I look at the x's, it goes from 0 to 1, that's plus 1, 1 to 2, that's plus 1, 2 to 3, that's plus 1, that's good. For the y's, 6 to 12 is plus 6, 12 to 20 is plus 8, 20 to 30 is plus 10. Those are not constant. You do the second set. To go from 6 to 8 is plus 2, and to do from 8 to 10 is plus 2. The directions say, tell whether each function is quadratic, explain. This is quadratic, and my explanation is simply showing my steps here. Okay, this shows that the second set of differences are the same. So you could try the same thing. On this number 2, you look to see if you have an x squared, if you have a degree of 2. On the second part, here's where you have the tables, and you're just going to fill them in. So for your domains, I would probably choose negative 2, negative 1, 0, 1, and 2. You're going to plug them into the equation. So to plug in this first one, it would be negative 1/2 times negative 2 squared. I plugged in the negative 2. Negative 2 squared first. Negative 2 times negative 2 is 4. Then I ask myself, what is half of 4, which is 2? And it's going to be negative. So it'd be negative 2, negative 2. And then I would graph that, negative 2, negative 2. And you would keep doing that until you graph it on both of those. On the next part, tell whether each graph is quadratic. Tell whether the graph of each quadratic function opens upward or downward. Make sure it's in standard form. And once it's in standard form, look to see if the coefficient, if the A term is positive, it's going to open upward. If the A term is negative, it's going to be downward. For the bottom part, for each parabola, identify the vertex, then give the minimum or maximum, and then find the domain and range. That's a lot of steps. Okay, so A, identify the vertex. You're just going to write the order pair for it. What is the order pair for that vertex right there? It is negative 2, 6. So I just write that on A, negative 2, 6. For B, it says give the minimum or maximum. Well, if we look at the Y number line, the highest that it hits it is a 6. So the maximum is 6. And then the third part, give the domain and range. With the domain, it's going to be all real numbers because it has arrows on it, and it's going to reach indefinitely. For the range, y, notice that the highest point is 6, and then it's going to go down. So y is less than or equal to 6 because it's 6 in all the numbers below. So that kind of walks you through some of that. We all love these problem-solving ones. Okay, let's look at this to give you a little help. Okay, if you look here at the, if I can get this to come down a little bit. If you look at the thing, we only have a 1-quadrant grid here. So if you look down here, it's wanting you to fill in some x, some numbers for the domain. Well, if you look down here at the domain, it starts at 0. So use the numbers that they give you on the graph. So since they start with 0, I'm going to use 0, 1, 2, 3, 4 because those are the first 5 numbers on my x-axis down here. Now to figure out the y, or the f of x, I have to plug in the numbers to this equation. So if I plug in a 0 to this equation, and this would all be 0, and this would all be 0, so it would just equal 4. So when I graph that at 0, it would be 4. When I plug in 1, you have negative 16 times 1 squared plus 64 times 1 plus 4. All I did was plug in 1 to each of the t's. When evaluating that, of course, you're going to do your exponents first. So 1 squared is 1. 1 times negative 16 is negative 16. Then we have negative 64 plus 4 and something there. Oh, that's a plus sign. I thought it was a negative sign. I couldn't even read my own writing. That's a plus 64. When you evaluate that, you're going to find that that would be 52. So at 1 second, it tells us that the height of the ball was at 52. And you're going to keep doing that with the next 3, and you're going to draw what the ball looked like after each second. It should look like a parabola. Okay, so with each one of these, you're just going to think through things that we talked about, and then check the key and see how you did and see if you can understand it. The last page that you're looking at for practice would be this one. Come on. It will not scroll down for me. Nice. Okay, so it's ask each one of these questions. What is the domain? Notice there are arrows, so the domain is going to be all real numbers. For the range, it starts at -4 and goes greater, so y is greater than or equal to -4. X-intercept, where does it cross the x-axis? If you look up here, it crosses the x here and crosses the x here. So you're going to write those order pairs as the x-intercepts. So it looks like it's crossing the x-intercepts at -2, 0. And it's crossing the x-intercept at 6, 0 because it crosses right here at 6, 0. The y-intercept says, where does it cross the y-axis? Well, it crosses the y-axis right here, which is 2. I'm trying to read what that says. Yeah, sorry. 0, -3. I read my own writing up there. The next one asks, where is the vertex? Well, the vertex is right here, which is 2, -4. The minimum value is -4 because that's the lowest it goes on the y-axis. The axis of symmetry, where if you were to draw a line down the center here, where would it be on the x-axis? That would be at 2. And does it go up or down? It goes up. So kind of work through these and get ready to take your assessment.